Hello, everyone. My name is Erica O'Hara, and I will be presenting this training where we will explore the seamless integration of serial devices into Ethernet networks, unlocking new possibilities for efficient data communication and control in modern industrial applications. In this presentation, we will explore serial devices and how they can be integrated into Ethernet networks to enhance communication and control abilities. We'll begin by looking at some common serial devices such as barcode scanners, sensors, PLCs, and industrial controls, which traditionally rely on serial communication protocols like RS-232 or RS-485. Then we will discuss the benefits of integrating these devices into an Ethernet network, including scalability, remote access, and enhanced flexibility. Next, we'll review various serial to Ethernet solutions that bridge the gap between legacy devices and modern networking technologies. To illustrate these concepts, we'll share real-world application examples that demonstrate the advantages of these integrations. Finally, we'll walk through the basic setup steps to ensure smooth implementation of serial to Ethernet solutions in your systems. ICP DAS, founded in 1993 in Taiwan, specializing in data acquisition, communication, and control solutions. In 2001, ICP DAS USA was established to better serve the North American market, offering local sales, support, and customized solutions. Together, the ICP DAS in Taiwan and our office here in USA continue to provide innovative and reliable industrial communication products, including serial to Ethernet solutions, remote I/O systems, and protocol converters, helping industries optimize data communication and streamline operations. Common serial devices used in industrial automation include programmable logic controllers, PLCs, human-machine interfaces, HMIs, industrial sensors, barcode scanners, motor controllers, remote I/O modules, and barcode label printers. These devices rely on serial communication protocols such as RS-232, RS-485, and Modbus RTU to communicate to communication protocols such as RS-232, RS-485, and Modbus RTU to interface with other systems. PLCs and HMIs use serial ports to connect with sensors and control systems, while industrial sensors send data to central systems. Barcode scanners and label printers are used for inventory tracking and data collection, and modern motor controllers utilize serial communication for controlling mechanical systems. Remote I/O modules enable long-distance connections between devices and controllers. Despite the widespread adoption of modern networking technologies, serial devices continue to play a vital role in industrial controls due to their reliability, simplicity, and cost-effectiveness. Many legacy systems and critical equipment still rely on serial communication protocols like RS-232 and RS-485 because they are robust, well understood, and capable of operating over long distances with minimal interference. For industry with existing infrastructure, integrating serial devices with newer Ethernet networks allow for seamless communication without the need to replace older equipment. We continue to support these devices by providing serial to Ethernet solutions, ensuring that industry can modernize their systems while maintaining compatibility with their legacy devices. This approach helps maximize the lifespan of existing equipment and ensures that industrial control systems remain efficient and reliable. When deciding between Ethernet and serial communication, it's important to consider the specific needs of the system. Ethernet is typically chosen when higher data transfer rates are required, as it supports much faster speeds than serial communication, making it ideal for applications that need to handle large volumes of data or time-sensitive operations. Additionally, Ethernet is highly scalable, allowing for easy expansion, making it the preferred choice for large industrial environments that need to connect numerous devices over wide areas. Ethernet also supports advanced network architecture and control features such as remote monitoring, communication protocols, and quality of service. Furthermore, Ethernet is the ideal option for systems that need to connect to the cloud, allowing for remote access, data storage, and analysis, which serial communication cannot easily support. In contrast, serial communication remains a reliable and cost-effective choice for simpler legacy systems or when a straightforward point-to-point communication link is sufficient. While serial communication excels in specialized or small applications where reliability and low cost are priorities, Ethernet is better suited for modern industrial applications that demand high-speed data transfer, scalability, and seamless integration with broader network infrastructures. Integrating serial devices into an Ethernet network offers numerous benefits that enhance system functionality and streamline operations. By converting serial communication to Ethernet, devices can be accessed and monitored remotely over long distances, providing greater flexibility for managing operations from centralized locations or even across different regions. This integration also enables scalability, allowing systems to grow by easily adding new devices or expanding the network without significant changes. Ethernet's higher data transfer rates and increased bandwidth make it ideal for modern applications. In addition, Ethernet integration enables seamless connection to cloud platforms and the Internet of Things, enabling data storage, analytics, and remote management of devices in real time. Security is another major advantage, as Ethernet networks can support advanced security features like encryption, user authentication, and remote access control, which are essentially for protecting sensitive data in industrial and commercial environments. Additionally, integrating serial devices into an Ethernet network simplifies installation and maintenance, reducing the need for extensive cabling and lowering operational costs. When integrating serial devices into an Ethernet network, it is crucial to consider factors such as compatibility, security, network configuration, bandwidth, and scalability to ensure reliable and efficient communication. The goal is to bridge the gap between legacy serial devices and modern Ethernet-based systems, maintaining high performance, robust security, and the ability to scale for future expansion without compromising system integrity or functionality. The image you see illustrates how we use serial to Ethernet devices enable seamless integration of traditional serial devices into modern Ethernet networks. In this setup, legacy serial devices such as PLCs, sensors, or barcode scanners are connected to serial to Ethernet converters, which then translate serial communication protocols like RS-232 or RS-485 into Ethernet-compatible signals. This allows the serial devices to interface with Ethernet-based systems, providing remote access, centralized control, and enhanced scalability. The image highlights the flexibility and efficiency of these converters as they facilitate communication between serial devices and modern network infrastructure, enabling real-time monitoring and data exchange across long distances while reducing the need for extensive cabling and hardware upgrades. The TDS-712 and TDS-715 are powerful serial to Ethernet converters designed to seamlessly integrate RS-232, 422, 485 serial devices into Ethernet networks. These devices support a wide range of applications, including serial-to-serial bridge and serial tunnel setups, offering flexible communication options for industrial environments. They come with VXCOM drivers for both 32-bit and 64-bit Windows, BIT Windows, enabling easy software integration. The TDS 712 and TDS 715 feature both static IP and DHCP network configuration options, making them adaptable to various network setups. Their buildup in the web server allows for simple serial and network configuration via HTTP, streamlining setup and management. Additionally, these converters support automatic RS-485 direction control, ensuring smooth communication without manual intervention. With a compact form factor and low power consumption, the TDS 712 and 715 are ideal for space-constrained environments and energy-efficient operations, making them perfect solutions for modernizing legacy serial devices in industrial applications. Our TDS series provide reliable solutions for converting serial communication to Ethernet, allowing legacy RS-232, 422, and 485 devices to seamlessly integrate with modern network infrastructures. These devices enable bidirectional communication between serial devices and Ethernet networks, offering flexibility for a wide range of industrial applications. With support for features like VXCOM drivers, automatic RS-485 direction control, and easy configuration via a built-in web server, the TDS series simplifies the process of connecting serial devices to Ethernet, enhancing scalability, remote monitoring, and data exchange capabilities. Our TDS series offers a pair mode feature that enables communication between two serial devices over the internet. In pair mode, one TDS device acts as a server while the other acts as a client, effectively creating a direct connection between the two devices through an Ethernet network. This setup allows serial communication between the devices even if they are located at remote sites, over long distances, or through the internet. This capability is particularly useful for applications where devices need to be connected across long distances without relying on expensive modification. By using the TDS series in pair mode, it is easy to enable remote monitoring, control, and data exchange between devices, making an ideal solution for industrial systems and applications that require real-time communication. The TDS series includes the TDS 712, 715, and 718 models, which each offering different features for integrating serial devices into Ethernet networks. The TDS 712 supports RS-232, as you can see in the table. TDS 715 supports RS-422 and RS-485 communication. We also have model with 2 and 3 ports for additional device connections. All models are available in versions with isolation, protecting devices from electrical surges and noise, making them more suitable for industrial environments where reliability and safety are crucial. The TGW series is a cost-effective Modbus gateway that supports Modbus TCP and Modbus RTU ASCII in both master and slave configurations. It allows up to 32 TCP connections per serial port and offers flexible network configuration with static IP or DHCP support. The gateway also includes a web server for easy configuration via HTTP through a browser. The application diagram that you see shows the TGW 725 as a Modbus TCP to Modbus RTU gateway. And it shows how it converts communication between Modbus TCP-based devices and Modbus RTU devices within an industrial network. The TG725 serves as a translator, converting Modbus TCP requests into Modbus RTU communication for serial devices. This enables seamless integration of legacy serial devices with Ethernet-based systems, allowing for remote monitoring, control, and data exchange across different protocols. The TGW 725 can also function in the opposite direction, acting as a Modbus RTU master to a single Modbus TCP slave. In this configuration, the TGW 725 allows a Modbus RTU-based system to communicate with a Modbus TCP device by converting the Modbus RTU master commands into Modbus TCP requests. This functionality enables the integration of older RTU-based devices with modern TCP-based systems. Whether converting from Modbus TCP to RTU or vice versa, the TGW 725 provides a flexible and cost-effective solution for bridging communication gaps in the industrial automation system. Like the TDS series, the TGW series also supports paired connection for creating a serial tunnel, allowing two devices to communicate over an Ethernet network as if directly connected via a serial cable. This feature is ideal for remote applications, enabling seamless communication between serial devices over long distances and enhancing scalability in industrial systems. Our TGW series offers a range of models for different Modbus gateway applications. The TGW 715 comes with a single RS-485 port for converting Modbus TCP to RTU communications. The TGW 712 offers a single RS-232 port. The 725 has two RS-488 ports. Finally, the TG-735 has three RS-485 ports, and the I versions are for isolation for protection against electrical interference in harsh environments. The PPDS, PDS, DS, TDS, and TGW series offer different solutions for integrating serial devices into Ethernet networks. The PPDS series focuses on simple serial to Ethernet conversion with basic features. The PDS series offers more advanced functionality, supporting multiple serial ports for more complex networks. The DS series is designed for high-performance serial to Ethernet communication with additional features for industrial application. The TDS series supports a variety of serial communication protocols and includes features like pair connection for serial tunneling and web-based configuration. The TGW series serves as a Modbus gateway, enabling communication between Modbus TCP and Modbus RTU devices with additional features like Modbus pair connection isolation options. The MDC-711 Modbus data concentrator is a device that collects data from multiple Modbus RTU devices and transmits it over a Modbus TCP network. It allows seamless communication between serial devices and modern Ethernet systems, centralizing data from up to 16 Modbus devices for easier monitoring and management. The MDC-711 Modbus data concentrator collects data from the Modbus RTU devices like sensors, RTDs, and on and off switches, and transmits it over a Modbus TCP network. As you can see here, it consolidates data from these devices, such as temperature readings from RTDs or binary status from switches, into a single output. This enables real-time monitoring and control of multiple devices via a modern Ethernet network, simplifying the integration of legacy Modbus RTU devices into centralized systems. The TSH-700 series is a family allow users to connect and monitor sensors and other field devices in industrial environments via Modbus RTU or serial communication protocols. They offer several key features that make it versatile and efficient for industrial communication. It supports baud rate conversion, supports Modbus RTU protocol conversion, raw data mode for most query response protocols that are not Modbus based, but either RS-485 or RS-232. With a built-in web server, the TSH-700 series simplifies the configuration process through a web interface, allowing users to set up and manage the device via Chrome or Edge browser. The recache feature stores frequently requested data, ensuring quicker responses during data retrieval and improving the overall performance of the system by reducing response times. The TSH-700 series can function as a Modbus share, allowing multiple Modbus master devices to communicate with one or more Modbus RTU slaves. This feature enables simultaneous communication between two or more Modbus masters and a shared set of slave devices. By acting as a bridge, the TSH-700 series manages and routes communication between the masters and slaves, ensuring that data is transmitted correctly without conflict. This makes it ideal for complex systems where multiple control systems or monitoring stations need access to the same set of slave devices, simplifying system integration and improving network efficiency. How to set up a Modbus TCP to Modbus RTU gateway. First, here is the setup that we are presenting. Power the module either using a PoE or a standard 1248 VDC power supply and connect to your PC either directly or directly through a network switch or router. With the module powered, open our eSearch utility and search for a module using search server. If the module is not found, you have to make sure virus and firewall software are not blocking the search. Also, if you have other networks like wireless enabled, temporarily disable these additional connections and research server. Once it is found, double click on the found TGW module to set up network properties. Robert, are you here? Because since you are our application engineer, maybe it's best that you talk about how to set up these. Modbus gateway, yeah.
Okay, these are just screenshots, but from once you set the IP address to be on the same network as your computer and master device, you can double click on the module as shown in blue at the top, and it'll bring you to the web page. You can also type the IP address into Chrome or Edge browser and bring up the same web page. It'll prompt you to log in. By default, the password is admin, all lowercase, but once you log in first time, you can change it by clicking on the password on the right side of the top menu. Okay, once you log in, it'll bring you to the home screen. The home screen will look like this. It shows an overview of how the module is currently configured. The module shown here has 3 ports, shown at the bottom, port 1, port 2, port 3, so this would be a TGW 735 module, but the 715 would have 1 port, and 725 would have 2 ports. If you want to change the configuration of any of the ports, at the top menu bar, there's port 1, port 2, port 3 for this module. You would click on port 1, for instance, if you want to change the baud rate for devices connected to port 1 of the TGW module. You can also view the network settings. Previously we set the network settings using our eSearch utility the first time, but if, for instance, you want to install this at a customer site once you have everything configured, you could simply click on network at the top, and that would bring you to the network settings where you can modify the network settings to match your customer's devices. You can set filter options. The monitor tab, which we'll show you in a little bit, will help you in troubleshooting. But let's move on to the next screen, Erica. Okay, so The main thing you want to do for the port 1, port 2, and port 3 setup when doing a Modbus TCP to Modbus RTU gateway is to match the baud rate and parity options for the RS-45 bus. You want to match your slave devices if the baud rate or parity option is wrong, or you have multiple devices with different options. You'll need to change those. So the idea is to get all of the devices on that specific port to have the same communication parameters. Okay, so next, this is an overview of the system diagram after the fact. Let's see, in this diagram we have a Modbus TCP master on the left side. It's a computer, but it can very easily be an HMI or PLC connected to 3 of our power meters. The power meters have different net IDs. This is very important. Let's see, net ID 1, net ID 2, net ID 3. This is the Modbus ID that you'll reference in your Modbus requests. With Modbus TCP, traditionally, you don't need to worry about different Modbus IDs. Traditionally, it's just one. But for this architecture where you have one Modbus TCP master communicating with multiple slave devices, specifying the slave device ID is important and part of the setup you'll need to do on the Modbus master side. And you just simply reference the Modbus register table for those specific devices. They don't all need to match. In this case, they're all ICP DAS power meters, but it could very well be Modbus RTU data acquisition modules by us or by third parties. Second PLC set up as a slave device, but you just need to reference the Modbus register table for those specific modules and just simply create your request from the Modbus master and send it to those slaves for those specific pieces of data. I'll go to the next slide. This is the monitor tab, which I explained slightly earlier. It shows you the number of connections. If, for instance, this one shows available connections 32, which is the maximum number. If your Modbus master is connected and polling, that number will decrease. If you see 32 there, that means that your master device is not connected. So maybe check your Ethernet connection or make sure that it's powered on and get the connection first. Once you're connected, then you'll start seeing the queries and everything start increasing or incrementing. At the bottom of the screen shows the last error, first error, and number of Modbus requests. This is very valuable information for troubleshooting. For instance, it'll show you if there's a timeout on the slave device, or if you don't see any bytes increasing, then it's on the master side that you need to check the configuration for. But this screen it's helped many customers to troubleshoot their Modbus gateway features. Usually it's a wiring issue or a setting problem, but the error codes on the monitor tab are very valuable.
I also wanted to let everyone know, I'm not sure if everyone knows this or our customers know, but we are looking in search for application stories where if you use our products, we want to hear from you. We want to know the story, what industry you're in, and how our products are helping you with your application. We are giving $300 to the engineer who submits their story. If you're interested, please email sales@icp-usa.com and I'll send you the link, and you just answer a couple questions and attach some photos, and I'll create the story and then send it to you for approval. And that's it. Thank you all for attending. Hope you guys have a happy holiday time next week. And next month, our webinar, we are partnering with Aviva Edge. So we will have a guest speaker from Aviva join in our webinar, how their software integrates with our products, and hope you guys attend to that.
Yeah, if you have any questions about these products or any other products, please feel free to contact us, and we'll be happy to go over your application, go over the product, or answer any questions you may have.
Thank you for coming. Bye.
Hope you all have a wonderful holiday.